students, this is channel. We are discussing example number 1 for wind load calculation. This is video part 2 for that. Now let us have a brief about the problem and then we will move ahead. So up to now we have considered example number 1 as 20 by 30 meter in plan. A building is there, beam width is 5 meter in both the direction, story height is uniform, location is given as Surat and category is given as 3. Furthermore, it is given that it is a building which is having slope less than 3 degree and life of the building is assumed as 100 years. So our target is to find out nodal point loads as well as wind pressure diagram. Let us move. So in the plan it is given that plan is having 5 meter bay in both the direction as is shown in the figure. Furthermore, we have discussed step 1 and 2. In step 1 and 2, it was nothing but we have found out Vz or Vd and Pz or Pd. So basically, these both are required to find out wind pressure diagram or nodal point load diagram. For that, we have found out the formula Vb into K1 into K2 into K3 into K4 is equal to Vz. Now, we need 5 things. For 5 things, VB, basic wind speed at Surat. For that, we have followed Appendix A, page number 51 from IS 875, Part 3, 2015. Now, after VB as 44, we will move to K1. K1 is directly got from page number 7, table 1 for 100 years. K1 will be 1.07. After that, K2, there is a table given in table number 2 in IS code as shown in the figure, and from that I have took the values of 10, 15, 20 and 30. Here my building height is up to 30 meters, so I have took the values like this. Otherwise you can take more of that also. After K2, we will choose K2 like in terrain category given in the problem. After K2, we went for K3. K3 is a topography factor and it is clearly written in clause number 6.3.3 and 6.3.3.1 that K3 should be 1 when the slope of the building is less than 3. We will understand some more problems which are having slope greater than 3 as well. Now, after K3, we will move to K4. According to IS code, K4 for all the structures, all other structures rest than shown here is taken as 1. It is given on page number 8 and 9. After K1, K2, K3 and K4 as well as VB, we can find out KD, K and KC so that we can move to VZ or VD and PZ or PD. For KD, KD is taken as 0.90. Now it is taken according to page number 9 and 10 given in IS code clause number 7.2.1. Same way KA. For KA we have to find out tributary area, and tributary area is taken as center to center column distance into center to center beam distance, and that is how we got tributary area as 25 meter square. And from our 7.2.2 and table number 4 we can take KA as directly 0.90. If the KA is in between 10 to 25 or 25 to 100 or more than 100 and less than 25, we can interpolate these values. Now for KC, we have taken KC as, here KC is a combination factor, and so that KC should be taken as 0.90 according to clause number 7.3.3.30. Combination factor is nothing but whenever the pressure is in a similar direction, it means that if there is a building and wind is acting on that, and the wind will try and go upwards, right? But if it is in a combination, if the wind will go upwards from the windows as well as it will act in the opposite direction from the roof also, then Kc should be taken as 1. But in our cases, whenever in question there is nothing given as like this, we have to take Kc as 0.90 only. So after getting Kd, Ka and Kc, we can move further to our next thing, that is a table. Now in here you can see height variations are taken according to K2, 10, 15, 20 and 30. In this table, Vb value will be constant as 44, it is in the same region. K1 value will be constant 1.07. K2 will move according to IS code table, and we have taken the K2 value previously, same value will be put here. K3 will be same for all the heights 1. K4 will be same as 1 in all the heights. Now we will find Vz or Vd. Vz or Vd is nothing but Vb into K1 into K2 into K3 into K4. So basically it is multiplication of column number 2, 3, 4, 5 and 6. I am getting Vz or Vd for 10 meter 42 point something, for 15 meter 45 point something, for 20 meter 47 point something and 30 meter 49 point something. So these are Vd or design wind velocity, we can say. After that, I will move to Pz. Pz is nothing but 0.6 into Vz square. So we have got Vz, I will do its square and multiply it with 0.6. So I'll get Pz as shown in the table. After Pz, I will calculate Pd, design wind pressure Pd. Now its unit will be Newton per meter square. Keep that in your mind. Now Kd into K into Kc into Pz will give me the answer. Now I have the Kd, Ka and Kc. In the previous slides we have found out Kd, Ka and Kc. Kd should be taken as 0.90, Kc should be taken as 0.90 and Ka should be taken as also 0.90. Keep one thing in your mind, Kd into Ka into Kc should not be less than 0.70 according to IS code. So I have taken it as Kd into Ka into Kc all as 0.9 and multiplied it with Pz. So I am getting Pd as 802.85, 912.18, 989.003 and 1089.349. Now I have different wind pressure for different heights. So you should understand that if my building is of height 10 meter, there will be a less pressure. If it is of 15 meter, there will be more pressure. It is of 15 meter, 20 meter, it will be having a great pressure. So likewise, when your height of the building increases, wind pressure will increase, as we see generally. Let us move to the next slide. Now we have to find out design wind load. F. This is our step 3. After step 1 and step 2, IS code page number 32 suggests us for wind load calculation, we have to multiply CF into AE into PD. Now, AE and PD. PD, we got that in the previous slide, that is PD. Design wind pressure. Now I want CF and AE to be find out. So now I will find out CF. For CF, IS code has given us a chart. Here in this chart, one axis, which is Y axis, is showing CF. But these lines should be given by H by B value. Here first line you can see H by B for 1, H by B 3, H by B 5, 10, 20 and infinity. Same way the x-axis should be given as A by B. So A, H and B are to be found out. In this figure they have shown how to take A, H and B. Simply H is the height of the building. For A and B, here this is showing a plan dimension. This figure is showing a plan dimension. In this figure, A should be taken as the lesser dimension and B should be taken as the higher dimension or the more value dimension. So we will take A as 20 meter and B as 30 meter, as well as height of the building is given as 30 meter. So I have A, H and B. After that I will find out A by B and H by B. So finding out H by B, it will be 1 and A by B will be 0.667. Now I will put A by B value here. I will see the A by B, that is 0.667, so the line will be somewhere here, and H by B is given as 1. So H by B 1, that means it is the first line. So I will take some value from here in the graph and the value will be get as shown in this. Now the value will be between 1.20 and 1.25. So it will be taken as 1.22. It may happen in the exam that all the values taken from chart according to your different mind, students, that may change, and it will be allowed if it is in a proper range. So don't worry if you don't get 1.22 same exact value as mine. Let us move further. After getting CF, I will move to AE. Now what is AE? As explained in previous videos, effective frontal area. It is nothing but a ratio, and from the ratio I will get area. Now how to calculate that? Let us see. Length of building or length perpendicular to the wind load. So it will be 30 meter in the plan, and number of columns in that direction. So in the direction, how many columns will be there? So let us see again our plan of the building. Here I can see 1, 2, 3, 4, 5, 6 and 7 columns, and 30 meter, which is dimension perpendicular to the wind. So I have taken 30 by 7 and AE comes out as 4.285 meter. Now I have the formula of F, CF, AE and PD. I have all three values, but PD is different for every height. That is why I have to take it in a tabular form, and this table is prepared. Height for 10, 15, 20 and 30 as previous. PD is also taken as previous values from this table. Now third column is design wind load, that is F, CF, AE into PD. So AE value is 4.285, CF value is 1.22, and multiplying it with PD, I will get these values. These values are in Newton per meter, but I will need these values in kilonewton per meter. So I have converted in kilonewton per meter by multiplying it into 10 raised to minus 3. So I will get for 10 meter height, F in kilonewton per meter will be 4.196, 15 meter 4.768, 20 meter 5.169 and 30 meter 5.694. Moving further, after finding out F, I will need nodes and idea about nodes. For that, I have to assume some dimension of the beam or height of the beam. So I will assume overall depth of the beam as 500 mm. It is assumed roughly approximately. So in every problem you should assume that as 500 mm for ease of the calculation right now. Now let me explain you some detailed explanation about nodes. Now nodes of the buildings are generally in the center of the beam. So here I have shown something. This orange line, orange area is showing column. This gray area is showing beam, and this green area is showing a slab. Now as it is, this line is given as ground line. This slab will be a base slab or floor slab, which is below the building ground floor of the ground. It will be below or than that. So this height will be approximately assumed as 1 meter height, and total height up to the foundation is taken as 2 meter. Now, for finding out the node from ground line to node, I will calculate something. Now, I have total height as 1 meter and beam width or beam depth is 500 mm. So, this center of the beam will be where? It will be at -1, which is below ground line. So, I have taken as -1 plus 0.500 by 2. So, it will be in the center of the beam. So, this distance is taken as minus 0.75 meter from ground line. All these node distances are taken in the reference with ground line. Keep that in your mind. Now talking about one another story, that is node 11. It is a first story, so we can take its height up to 5 meter. Otherwise, uniform height is assumed as 4 meter of every story. Here, as the height from ground line is 5 meter, for nodal distance, I will do 5 minus 0.500 by 2. 500 is overall depth of the beam. So center of the beam will be half the distance, and that is why 5 minus 0.500 by 2. So node 11 will be located at 4.75 meter from ground line. Now talking about node number 2, average height is 4 meter. So from ground line, node number 2 height will be 4 plus 5 will be 9 minus half of the beam height. So it will be 9 minus 0.500 by 2. It will be 8.75 meter from ground line. Same will be applicable for 3, 4, and furthermore. Here, if we focus on the ground story only, we can understand this image. Understanding this is very important. Now, I am finding out half of the range, or we can say loading level for the ground story. Now, we have to start the ground story from ground line, right? So, ground story is, we can say 0 to 4.75 meter height, and half of that will give me the range. That range will be used as loading level in this table. So if we talk about first column of the table, which is node, so GG or 00 node will be taken as minus 0.75 meter height. After that, node 1 will be calculated as 4.75 meter. Here we can see 4.75 meter. Node 2 will be 8.75 meter. Node 3 will be 12.75 meter. And if we add 4 meters height of every story, we can get all the node heights from ground line. Now, second column, which is loading level. So, we have distributed loading level according to our understanding like this. Here we can see for ground story from GG to 11, we will do what? We will do half of that. So doing half of that will make 4.75 by 2 as 2.375, and first loading level will got as 0.02 2.375. After that, for for 1 node, loading level will be distributed below 1 and above 1. So below 1 will be starting from 2.375 only. As we have to cover total height, we will start from the 2.375 only, and the above portion, then 1 will be considered as this, and above portion will be half of this. So it will be added half story above the node, half story below the node, and the calculation will give us 6.75. So node 11 is having a range of 2.375 to 6.75. We can see this in the picture, 2.375 to 6.75, which is half of the story and half of this story. Again, for next we will consider half of this story to half of this story, and so that we will start from 6.75 here, and the half of this story will be added as again 2 meter, 2 meter, so 4 meter will be added in 6.75 and it will be 10.75. Again 4 will be added same way upwards and parapet will be considered at top. So this is how we prepare second column. This is loading level. Let us move to next column, which is load in kilonewton per meter. Now this column is important and you must understand how to find this. To find out this, I will use my older table which was prepared previously, which was consisting of height PD, design wind load in Newton per meter and kilonewton per meter. So I have the height 10 meter and for that kilonewton per meter wind load is 4.196. But here I have different heights as 0, 0 or 0 to 2.375. So maximum height of these loading level will be 2.375. Here in the first story case, maximum height for this will be 6.75. In the second story, it will be 10.75. Third story, 14.75 and vice versa. Now, to find out different height, for an example, I have the wind load pressure kilonewton per meter F as 4.196 for 10 meter. But what about 10.75 meter? For 10.75 meter, I have to find out with cross multiplication. Let us see this slide. So up to 10 meter height, F is equal to 4.196 according to our previously prepared table. Now, if the height increases from 10 to 15, the pressure increases like this. 10 meter 4.196, 15 meter 4.768. So, if the height gap is 5 meter, the gap of wind pressure is 0.572. So, if the height increases by 0.75, as we are finding load for 10.75, what will be the pressure? So, this cross multiplication will give us the gap. The gap is 0.0858 and this gap should be added in the value of 10 meter because 10.75 is greater than 10 meter and 4.196 plus 0.0858 will become F as 4.282 kilonewton per meter. So my first value for 10.75 meter 4.282, I got this. So I got this value 4.282. Now for the next value, I have the height is 14.75, which is maximum height for loading level. For 14.75, I will again cross multiply. Same way 18.75. So for 18.75, I will see that if 15 meter pressure is 4.768, for 20 meter pressure is 5.169, and if the gap is 5 meter, the gap for pressure will be 0.401. So if the gap is 3.75, what will be the gap in the pressure? After getting the gap in the pressure, I will add this gap in 4.768 and I will get my answer as 5.068 kilonewton per meter. And this pressure will be applied on which? This pressure will be applied at height 18.75 or loading level of 18.75. So I will put this value 5.068 in the table here. So due to this point, I have put 5.069. Otherwise, we can take 5.068 also. So after that, I will find out for 20.75. Same goes for 24.75. Let us move to other. That is 26.75 meter loading height. For that, same cross multiplication will be followed and the gap will be added in the base value. So F for 26.75 meter becomes 5.52 kilonewton per meter. So I will put this value again here. Same applies for this. So I have prepared the column number 3 with the help of previous table and cross multiplication. It is quite simple. It can be taken as interpolation simply. Now I have to prepare nodal point load. For nodal point load, I will do what? It is a very simple. I will do loading level difference, and that difference of height will be multiplied to the load in kilonewton per meter. So nodal point load will be in kilonewton. So to get it in kilonewton, I will do what? I will do load which is in kilonewton per meter into the height in meter. Which height? The loading level difference. So maximum loading level is 30 here and minimum is 26.75. So the gap into load will give me nodal point load. Again, the gap into this will give me nodal point load. Same goes for ground. Here the gap is 2.375. So 2.375 into this load will become nodal point load in kilonewton. So it is in kilonewton. So final output for nodal point load, we got it in nodal point load in kilonewtons. Here this kilonewton values nodal point load, we will prepare a diagram from that. Same way for this load, or we can say wind pressure, we will prepare a different diagram according to each story. Let us see the diagram. Last step for this problem is this diagram. This diagram is divided in two parts: wind pressure diagram A, nodal point load diagram B. According to column number 3, this is a wind pressure in kilonewton per meter. So we will put the values in this diagram. 4.196, it will be increasing like that according to its value, according to its story. Same way, nodal point load diagram will be prepared like this, and in this we will use the nodal point load values as well as the different nodal heights as minus 0.75, 4.75, 8.75, etc. You can see this in the diagram: minus 0.75, 4.75, 8.75, and the center of the beam is shown and the wind force is shown on the nodes. So we have completed the problem. We will understand two more problems from this chapter, this type of problems only, in next videos. Thank you.